Hello guys. Today our topic is cable modem. We will briefly explain the technology of cable modem and the latest technology which is DSL, digital subscriber line, that may replace cable modem in future. At start, it show the history of cable modem from year 1979 to 2017. It included MITRE CableNet, IEEE 802.3b, IEEE 802.7, LAN City, Zenith Homeworks, COM21, CDLP, DVB, DAVIC, IEEE 802.14, IETF, DOCSIS and Multimedia over Coax Alliance. The next page is about the history of DSL. At year 1980, DSL technology works by using the existing copper telephone lines. It is dividing the telephone line into two separate channels, one for voice and the other for data. This enables users to make voice calls and access the internet at the same time, without one service interfering with the others. The first DSL standard, called a DSL, asymmetric digital subscriber line, was introduced in 1995. ADSL allowed for faster download speeds than upload speeds. A later version of DSL, called VDSL, very high-speed digital subscriber line, was introduced in the early 2000s and allowed for even faster download and upload speeds. Today, DSL technology is still used in many areas where cable or fiber internet is not available or too expensive to install. While DSL may not be as fast as other types of internet, it remains a reliable and affordable option for many households and businesses. The definition for the cable modem is a crucial piece of hardware you'll either receive from your internet service provider or purchase separately. It receives and sends the information like emails, web pages, text messages, and other data through the primary data connection. While the digital subscriber line DSL is a type of internet connection that uses the voice frequency of telephone lines to send and receive internet data and traffic, enabling high-speed downloads when the user is situated close to the DSL provider. How do cable modems work? The purpose of a modem is to connect your computer to your internet service provider, ISP. A cable modem does this by using a coax cable to communicate with your ISP and connect to the internet. A cable modem operates like a digital translator. It receives data from your ISP and translates it into something your router can understand. Your router then distributes the signal to your devices. This is how you get wireless internet, Wi-Fi, using a cable modem on your network. How does the DSL work? A DSL modem receives signals via telephone lines and converts them digitally for your use. This data can be transferred to you wirelessly or via an Ethernet cable. The use of existing telephone lines makes DSL accessible in rural areas as well as towns and cities. Phone lines have a higher capacity than required by phone calls, so DSL signals can easily piggyback across the same infrastructure. Next, we will present the factors contributing to speed limitations within the domain of cable modem technology. The first point is network congestion. Cable modems rely on a shared network infrastructure, which means that the speed of network connection can be affected by the number of users connected to the same network at the same time. The second factor is signal strength. The strength of the signal received by the cable modem can also affect its speed. If the signal is weak or unstable, the modem may not be able to achieve its maximum speed. The next point is cable modem hardware, which means quality and capabilities of the cable modem hardware can also impact its speed. Older or lower-end modems may not be able to support the highest speeds offered by internet service providers. Distance from the cable modem is also a factor in the speed limit. The farther away the device is from the modem, the weaker the signal and the slower the connection. Last is Internet Service Provider, ISP, plan. The speed of the cable modem may be limited by the Internet Service plan that the user has subscribed to. ISPs offer different plans with varying speeds, and if users have a lower speed plan, their modem will not be able to achieve higher speeds. Besides that, factors contributing to speed limitations within the domain of DSL technology have 5 of them. Distance from the telephone exchange is the first factor. DSL relies on the existing copper telephone line infrastructure to transmit data, and the farther away your location is from the telephone exchange, the weaker the signal becomes, and the slower the connection speed. Next, there will be the quality of copper lines. The quality of the copper lines can also impact the speed of DSL. Older or poorly maintained copper lines may have interference or noise that can affect the quality of the signal and reduce the speed. Network congestion also a factor. Like cable modems, DSL internet connections also rely on shared network infrastructure, so if there are many users accessing the network at the same time, the speed may be slower. Then, DSL modem hardware. The quality and capabilities of the DSL modem hardware can also impact its speed. Older or lower-end modems may not be able to support the highest speeds offered by Internet service providers. Last is Internet Service Provider, ISP, plan. As with cable modems, the speed of DSL connection may also be limited by the Internet service plan the user has subscribed to. Different plans offer varying speeds, and if users have a lower speed plan, their DSL connection will not be able to achieve higher speeds. Next is the advantages and disadvantages of cable modem compared to DSL. For the advantages of cable modem are potentially faster than DSL, more widespread than DSL, and the last one, it is cheaper than DSL. For the disadvantages for cable modem, it is less secure than DSL. The connection is shared with others, so speed will be very and limited usage. For the advantages of DSL are dedicated usage of bandwidth. It has higher speed than dial-up, and it is more secure than cable modem. For the disadvantages for DSL, it not widely as cable modem. The speed drop as you get further from phone company's central office, and it is expensive for service installation. This is the part for the current usage and usage conditions of cable modems and digital subscriber lines in Malaysia and other parts of the world. The use of cable modems is accelerated by the COVID-19 pandemic. The COVID-19 calamity creates an impetus for more and more internet-dominant activities. As office work and schooling activities move into the virtual environments in homes and personal residences, the use and necessity of cable modems spiked drastically. The sales of cable modems soared enormously in the world as more and more important tasks go onto the internet. As for the technological presence of cable modems in Malaysia, the cable modem technology is still prevalent in huge institutions like public universities and huge companies, even though the wireless internet systems have been flourishing in the recent years. In Malaysia, homes and most businesses have been losing their dependence on cable modems as society massively transitions into wireless technology like Wi-Fi and mobile data. Nevertheless, the institutions and internet-consuming entities that find restructuring and re-engineering the networking infrastructures in their systems to be costly and too massive still proceed with success. The current usage conditions of the digital subscriber line technology in the world are slowly and steadily diminishing from the primary forms of internet connection providers in the world. Cellular networks and the proliferation of mobile devices have made 4G LTE and 5G internet technologies more desirable than the DSL technologies. Nevertheless, in areas and townships with very well-established DSL internet providers, this form of internet technology is still prominent and relevant. The technology of digital subscriber lines in Malaysia are earmarked by the telecommunications giants of Maxis and Telekom Malaysia. As of June 2012, there were 1.705 million DSL connections in Malaysia. The internet speed of DSLs can reach up to 50 megabits per second maximally.